Good afternoon, guys. So you are officially done with reviewing linear functions. So from here on out, we'll take about 3 days or so, 4 days, and take a look at quadratics. And so quadratics are just anything where your biggest exponent is 2. So for example A, you have a 7k squared. 2 is your biggest exponent, so it's a quadratic. The first topic that we're going to look at with quadratics is how do I factor them, okay? Because that's a topic that you see quite often in lots of different math classes. So just a couple things to remember. When somebody asks you to factor something, what they're asking you to do is to break it apart into smaller pieces that are easier to deal with. The other thing that I want to remind you, the purpose of factoring is to help us solve an equation. Well, factors and solutions always have opposite signs. So let's take a look at example A. You've got an equation there, and we're asked to factor and solve it. The first thing that I always look for when I go to factor something is do my two terms here, so 7k squared and 9k. Do they have anything in common? And in this case, the answer is yes. They both have a k. So my first step in factoring is to pull out that k that they have in common. So I write it down. Then in parentheses, I'm going to list what they have left after I pull out that k. So in the first term, the 7's still there. I didn't touch it. But you had two k's. You pulled one of them out front, so now you only have one left. Bring down my plus sign. Then I look at the 9k. Well, I've already pulled the k out, but the 9 is still there. Here's where you have to pay attention to your instructions on today's assignment. If they just ask you for factors, there's your answer right there. You're done. Okay? Factors are just what are the pieces of this equation. But if they ask you to solve, you're going to have one more step. Okay? To actually solve, this equation is equal to 0. So you are now going to take your two factors, okay, so one of them is k, one of them is 7k plus 9, and set both of those equal to 0. Okay? So k equals 0, and then we'll come over here and do the other one. 7k plus 9 equals 0. Now, here's the thing. One of these equations is already solved. K equals 0. There's nothing else I can do with that. But I've still got to get k by itself over here on this right factor. Well, how do I do that? Well, I start by subtracting the 9 and then dividing by 7. So your second answer is actually going to be a fraction, and that's okay. Your second solution is k equals negative 9 over 7. So notice how your factor here, 7k plus 9, was positive, but your solution was negative. Okay? So two solutions there, 0 and negative 9 over 7. All right, looking at example B, the only thing that's different about example B is now you've got 3 terms instead of just 2. But it's the same steps. I say, okay, what do these 3 terms have in common? Well, 5, 15, and 20 all have a 5 that can be pulled out of them. So as I start to factor this, the first thing I do is write down that 5 out front. And then in parentheses, I list what's left after I pull out a 5. Well, for 5n squared, you got rid of the 5, but the n squared is still there. Okay? Then I go to the 15n. Okay, so I pulled a 5 out of 15. Well, 5 times 3 gets me back to 15, so there's a 3 left there. Bring down my minus. I pulled a 5 out of 20, so 5 times what gives me 20? 4. Okay, so there is step 1. Here's what's different about example B now. I can actually split this up even farther. Okay, I can look at what's in parentheses, and here's how I factor. You may remember we called it the X method earlier this year. Okay, so you can draw out an X. But what I'm doing is I'm saying what multiplies to negative 4, so what multiplies to my last number, and adds to the number in the middle, so to 3. So two numbers that multiply to negative 4 and add to 3. Well, think about what multiplies to 4. 1 and 4. Okay? So how can I get a 1 and a 4 to add up to 3? Well, 4 minus 1. So look at how I write that. Positive 4 and minus 1. Okay? And let's see if I can draw out that X method to show you how I got that. I may be able to, but it may be a little messy, but we'll try it. Okay? So here's my X, just to show you how I got this. Negative 4 went on top. That is a terrible 4. And 3 went on bottom. And I said, okay, what multiplies to negative 4 adds to 3? Well, 4 and negative 1. Okay, so that's how I got those two factors right there. That 5 that I pulled out front just kind of sits there. Okay, I'm not going to really do anything with it in step 2. There's my factors. If it says factors, I'm done right there. Okay, but here's the thing. If it asks for solutions, I'm not done. I've got to take each piece and set it equal to 0. So I say, okay, this time I have 3 pieces. So I set 5 equal to 0. Then I come over here and I set n plus 4 equal to 0. And then n minus 1 equal to 0. And I'm going to solve each piece. So let's take it step by step. Okay, if I look at the first piece, 5 equals 0. That is not a true statement. So that's not an answer. 5 is not equal to 0. Okay? So here, 5 would not be a solution. I can just kind of say not true or something like that. Not true. But I can solve the other two. Okay, if I have n plus 4 equals 0, how do I get n by itself? Well, I subtract it to the other side, so I get n equals negative 4. Okay? Then I go to the last one. I can solve it too. I want n by itself, so how do I do that? Well, I take that negative 1 and add it to the other side, so I get n equals 1. So even though I had 3 factors, I only had 2 solutions. That first factor gave me a statement that was not true. Okay? So 2 solutions here. All right, example C says factor and solve this right here. So the first thing that I check is there anything in common between a 1x squared, negative 16x, and 63? And the answer is no. There is nothing that goes into all 3 of those terms. So what do? Well, I go ahead, and at that point, I just make my x. So I say, okay, what multiplies to 63 and adds to negative 16? That was a terrible 6. All right, well, that ends up being negative 9 and negative 7. Okay, so that tells me right there that my factors end up being this. They end up being x minus 9 and x minus 7. So if it asks for factors, you stop right there and you don't go any farther. Okay. However, if it says solve, I have one more step. I have to set each piece here equal to 0. Okay, and solve it. So x minus 9 equals 0, and x minus 7 equals 0. Well, when I solve those, what's going to happen? Well, my solutions will have opposite signs. So your solutions here are going to be x equals 9 and x equals 7. And right there, you're done. So x equals 9 and x equals 7. All right, very last type of equation that you could see is something like example D. And again, I always check, is there anything in common between 36 and 49? And there's not. But there is something special about 36 and 49. This is what's called a difference of squares, because 36 has a square root, and so does 49. So how do I factor something like this? Well, the easiest way is to do this. Split up the 36 first. Okay? So what times itself is 36? Well, 6. And that's going to go with the x, because 36 is with the x squared. So each parenthesis is going to get a 6x. Then you come back and you say, okay, what times itself gives me 49? Well, that's a 7. So each parenthesis is going to get a 7. And then your signs in the middle, one is going to be positive and one is going to be negative. So there's your factors right there. Okay? Now, if you want to solve this, you'd take each piece, set it equal to 0. When you do that, you find out that your solutions end up being x equals negative 7 over 6 and x equals positive 7 over 6. Okay? And right there, we are done with today's notes. Go ahead and get started on the quizzes, and please let me know if you have questions.